The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Well, the goal is to introduce the students for the first time to physics. That's to say, calculus-based physics. Many students have already had some of that in high school, but many have not. And 801, the first course of physics, covers Newtonian mechanics. That's at the heart of the course. Depending upon the lecturer, we also cover fluid mechanics a little, and we cover a little of the kinetic gas theory. Well, this course is a general institute requirement. You either have to take this course or you have to take one that is slightly higher level, which we call 801-2. We evaluate the students through traditional exams. The lectures are given in the main lecture hall of MIT, 26100, and then the students meet in smaller groups with professors. We call those recitations, which is largely problem solving. I would like to think that every lecture is an event. And where possible, I go outside the standard curriculum. I talk about neutron stars, I talk about black holes, I talk about Big Bang cosmology. In a very natural way, do I introduce musical instruments. I talk about supernova explosions. And then during my last lecture, I introduce students to my research, the research I did during my early days at MIT when I made observations, astronomical observations in X-rays from very high flying balloons. Those balloons are giant in size, sort of the size of the Empire State Building, and they went up to an altitude of about 145,000 feet. And that's my last lecture. And all of these lectures are really events. Well, the course material on OCW, on my lectures, in addition to being the standard material that you expect from Newtonian mechanics, from fluid mechanics, and from kinetic gas theory, as I mentioned earlier, I try where possible to go a little bit beyond that and to make them see through the equations. And by doing that, I make them aware of the environment of neutron stars, of black holes, of supernovae explosions, of musical instruments. I only do that where it comes natural. But there are many places where it comes natural. So my goal is not so much to cover a lot and to make them chew on a lot of equations, but my goal is to uncover several very basic things that they will remember for the rest of their lives, even if they never need physics anymore. I want them to see the beauty of physics. I want them to love physics.